Okay, sometimes you're going to be asked to graph the derivative of the function when you've been given the parent function. And so I gave you a list of steps. First, you want to find the x values of any slope where f of x is equal to 0. And where that's equal to 0, that means your f prime of x are going to have x-intercepts. Then you want to plot those x-intercepts for f prime. Where f is increasing, you want to draw the y values for f prime of x above the x-axis because those are where the slopes are positive. Where f is decreasing, you want to draw the y values for f prime of x below the x-axis because that's where the slopes are negative. If f of x has any inflection points that change from concave down to concave up, that means there will be a minimum on f prime. If f has any inflection points that change from concave up to concave down, there's going to be a maximum on f prime. And just so you remember that when you take the derivative, the degree of any polynomial, f prime is going to decrease by 1. Alright, let's look at number 1. And if you notice, it is looks like a parabola, so that means we're talking about an x squared. So if I'm looking at an x squared, I know that the derivative of x squared is going to just give me something like 2x. So I know I'm looking at a linear function. And so I want to look at where my minimums are, or maximums. And so I have an extrema located right there. Again, extrema means a minimum or maximum. So that means I have an x-intercept located at x equals 0. And so from here, I want to look to see where is my function increasing or decreasing. Well, my function is decreasing down to 0. So if it's decreasing, that means my slopes are negative. And then it is increasing, which means my slopes are positive. And so if I was going to graph those values of the slope, if I have negative slopes, they become my new negative y values. And so my new negative y values are going to be down here. That's where my slopes are negative. And then where my slopes are positive, I was going to graph those slopes as y values. They're going to be above the x-axis. Now let's look at number 2. And again, let's find our maxes and mins. And so I have a maximum located there and a minimum located here. So we're going to go ahead and graph those x-coordinates on the x-axis. So I'm going to say it's pretty darn close to -3, so I'm going to put just to the left of -3. And it looks like this one, there's a minimum at 1, so I'm going to put the x-intercept at 1. Again, so these are the places, again, this is where the derivative is going to be equal to 0. If the derivative is equal to 0, that means it's an x-intercept. The next thing I want to look at is where is there a point of inflection for my f, because that's going to mean it's going to be minimum or a maximum on my derivative. And I notice that there's a change in inflection from concave down. So my function here is concave down, and then it changes to concave up. And so that means there's a point of inflection at -1. And so I want to graph that point of inflection. So if I'm concave down, that means my f double prime let me use a different color so you can see it better. Use blue. That means my f double prime is negative. If I'm concave up, that means my f double prime is positive. And so if you think about in terms of slopes, because we're talking about the derivative in comparison to the second derivative, if I have negative and then positive, that means that the first derivative is decreasing and then increasing. Well, that creates a minimum. And so I have a minimum at -1. So I'm just going to pick a random y coordinate. I'll say -3. And you can kind of see, since this is a cubic, this is x to the third, its derivative is going to be 3x squared, so you know you have a parabola. And so you can probably guess, you can probably connect the dots and create that parabola, but I just want to show you in terms of the y-coordinates for your slopes. So notice that your slopes are going up. Everything is increasing into -3 to this point up here. That means your slopes are positive. Then your slopes become negative. Let me erase some of the stuff in here so you can see better. Then your slopes become negative because my function is decreasing. It's decreasing down to here. And then finally, my slopes are positive again because my function is increasing. And so if I was going to graph those slopes, okay, so I'm thinking about my slopes become my new y values for my derivative. So I'm thinking about positive y values in red. Well, that means y values that are above the x-axis. And then I have negative, my slopes are negative, so that means I have negative y values. So that means I'm below the x-axis until +1. And then I have positive slopes, meaning I have positive y values above the x-axis.